All right, good afternoon. My name is Girish Pancha. I'm the CEO of a company called StreamSets. We're headquartered in California, global operations. We have over 150 customers, enterprise customers. We're an open source technology, open core technology. So we also have somewhere around 4,000 businesses that have downloaded and have used our open source product. We are looking at modernizing data integration. That's the area that I've been focused on the last 5 years. My background is actually in data integration. I was the chief product officer of a company called Informatica for many years, over a decade. I was at Oracle running their business intelligence tools. So I've been in the data analytics space for a very long time. Today, I want to talk a little bit about really what I think is happening, not just in the data integration space. I will spend some time talking about that, but really looking at it a little bit more broadly in the data analytics space and really try to give you my point of view here on what I think data ops is all about. Obviously, this is the data ops theater. You're going to hear lots of different viewpoints here. It is, I think, an early stage in the market, lots of different opinions. So hear mine out, and hopefully you'll take something out of it. Before I get into kind of the gory technology pieces, I want to just put out what I describe is kind of an audacious ambition or goal for data ops. This is what I think all of us, I assume many of you or most of you are data practitioners, and I'm going to put this statement out to just kind of talk about why I think we need data ops and what the potential for it is. And I think the reason we need data ops is that we make decisions, technology decisions especially, typically really focused on agility, supporting the business needs, being able to deliver something quickly. And my point is that we shouldn't be stopping that. We should actually make those decisions. But making those decisions leads inherently, I think, or typically leads to kind of chaos. Everybody's kind of doing their own thing. I think what data ops can do is tease order out of that chaos. And if we can do that, then really it's not just about a single project, a single application, a BI dashboard, etc. that we're talking about. I think we can actually get data ops embedded into all software development going forward. So that's really, I think, what we at StreamSets basically envision that we can help do. And it's not just us. We think it's a broader play. It's a lot of different technology vendors. It's a practice. It's design principles, etc. All right, so let's get going here. So why data ops? Over the last decade, we've seen this digital transformation wave come upon us where people started talking about effectively intelligence in the applications. And if you think about the previous decade or two, it was really just about automating business processes, etc. But you started hearing all sorts of point solutions and point stories about how an insight into a customer, better customer engagement led to greater revenue. You started hearing things around predictive analytics around IoT, predictive maintenance, how much can be saved by having kind of real-time intelligence built into your machines, and so on and so forth. And I'm not going to drain this because I think these are just categories of intelligence that can be applied to other categories, i.e. domains, and there's a lot more that's going to come as time goes on. Now this change, I think, has effectively being powered by the lifeblood for this change is data analytics. And if you look at what data analytics was a few years ago, it was really business intelligence. It was kind of periodic processing of data to look at some dashboards and reports to understand kind of what's happening with the business. But that's obviously changed. Now it's really around streaming. It's always on. You expect even your reports to always be providing you the right information. But of course, it's expanded well beyond that. So we've started hearing about data science, but what I'll put to you is that most of the stories around data science tend to be, again, one-off. Collect a lot of data, do a machine learning job on it, get a deep insight, and there you go, you can impact the business. I will say that really the next wave of data science is around operationalization. Okay? It's about making data science enable a culture of experimentation where you not just get that insight, but you put it to practice and you can continue learning and see what your insights are or what your changes are actually causing you to, what changes are, how effective those changes are. And if you think about that and take it to its natural extreme or natural end, it's really around applications having intelligence inside. You've seen this in the consumer world in the last 4, 5, 6 years, right? Started off with perhaps the voice-activated applications, your Siris and Google Assistants, etc. Really the form factor around mobile has changed that, right? Now everything we do now, we expect it to be very intuitive. You think about the logistics behind the ride-share companies, right? Now Uber, Lyft, etc. How much intelligence is in that application to make it that easy? Well, we've seen that in the consumer world. I think the business world, enterprises can very well do the same thing. It's a little bit more complicated, but the apps also are typically more specific. They're not situations where the app is a company. You want to actually have lots of different applications that can help with these business processes. And underlying all of this is, I think, if I were to say, what is the one common thing around all of these, it's really about having data continuously available for these data projects. And I think that's ultimately the goal here of DataOps, to provide continuous data to analytics. So let's kind of look at why this is a challenge. And I think the transformation is not just in the digital side, it's really in the IT side too. So if you look at IT transformation, what we've seen is really that every piece of the stack, from storage to compute to services, in this case now we talk about it as microservices or applications that are microservices, has changed, right? So I talked about analytics being embedded in these services. These are much smaller point services that can then be composed to support larger business processes. There's no notion of an owner here anymore. Everybody thinks they own various pieces of these services. So the supply chain is diffused across lots and lots of users, and it's pervasive. And when it comes to the lowest levels of the infrastructure, you've seen it. You're seeing it all around here. There's constant and accelerating innovation and change when it comes to data platforms, when it comes to infrastructure, the shift to the cloud, etc. So what's caught in the middle? It's your old data stores. Your data stores are caught in the middle between these two, and they've always been pretty fragmented, but they just continue to get even more fragmented. And I think, as you start thinking about the volume of the data, the different types of data, the different owners, etc., we're getting to the point where understanding data provenance is close to impossible. You just kind of shut your eyes, put your blinders on, and hope that the data you're working on is right. And as I indicated at the beginning, I think operationalizing this is really an afterthought. People really can do this once and not anymore. So you've got change in the business, you've got change in IT, and we at StreamSets have coined, when it comes to data, a term that we've coined as data drift. And we think data drift is a natural consequence of all these changes. And we've defined data drift as effectively the unexpected, unannounced, and unending changes to data that's being consumed in support of data analytics. So this could be semantic changes, it could be where the data is, it could be structural changes, etc. And I think really so far we've done one of two things. We've either ignored data drift or we fought it. Again, I'll talk a little bit about I think what that means in the next slide. But I think ultimately I believe we can not ignore it, we can accept it, and we can actually harness it, not fight it. So let's kind of get into how I think a traditional approach to this has worked. Okay, so first, you really almost always design for what I'd call the current state. You know what you know, you don't know what you don't know that's going to happen in the future. So you fix that, you spend a lot of time kind of understanding what this is, model it out, etc. Depending on how agile you want to be, you may understand a little bit of that. But then ultimately, it's about developer productivity. I was at our booth, people are talking about using things like AWS Glue to get the thing done the first time, and then so how's that working for you? Well, not very well after the first time, right? So developer productivity designed for current state is a default way to feel good about ourselves. We can go fast. Hope you can see that. And really, I think what you get is that, best case, a point solution. You often end up with a whole shadow IT organization. You've seen that also in the space where people have gone fast and try to avoid any control, any central IT function. And ultimately, look, this is ungoverned. It's risky. You run the risk of data breaches. You obviously run the risk of not being able to trust your data, etc. And this has been kind of known historically. So there's always the alternative solution that's also, I think, taken root, and that's one of what I'd call data governance. Now, data governance also really is designed for the current state. You spend a lot of time understanding what definition of whatever the entity is that you care about, customer, product, etc., and then you create a catalog. Then you try to enforce that everybody uses a particular catalog to get the job done. This sort of command and control, if successful, and often it isn't, but if it's successful, still leads to a terrible pain when it comes to change management. If something changes, it takes forever, and again, you end up finding actually that there become silos of governance and shadow IT, all kind of working the best they can. So basically, I think the mantra I think is really you can either go fast or be confident. I was reminded of this phrase a few years ago when Facebook kind of said that. They said, go fast and break things. They just assumed if you go fast, you are going to break things, and it's okay. You learn from that, right? So I think I would look at it as more as go fast or be confident. So I think with DataOps we can change that. So instead of these traditional approaches, first thing I think we do is really assume change. So during design, assume that there's going to be change, and really use technology to be more resilient to that change. That's what we describe as drift resiliency. The second concept, which I think is actually pretty well understood now, it really comes from DevOps, right? So instead of just thinking about the developer productivity, really think of this as a full life cycle productivity, and bring automation and monitoring through the whole life cycle to the problem. Now, again, a lot of people say, is DataOps just DevOps for data? Again, I think that's a trite question, because in some ways it is, but I think these other two ideas that I'm putting out, I think, are critical to making it DevOps. And the third one then is really this notion of emergent design. Again, it exists in DataOps, but it's got a different meaning, I think, when it comes to, it exists in DevOps, but it has a different meaning when it comes to DataOps. Because in DevOps, emergent design is really around your application. We don't really know what that application is going to do, but we're going to start getting going, and then the changes will let us know really what the application should do. With DataOps, I think you can do certain things so you can actually understand what the data infrastructure and what the data semantics, the data structure, all of that is on an ongoing basis, instead of trying to work that top down. So if you can do both of those, then I think we can both go fast and be confident. Go fast, agility, productivity, more business use cases, quicker, etc., and be confident with understanding that what the provenance of that information is, what the provenance of the data is, and apply the traditional qualities of data, service levels to data, around data quality, around data security, etc., and ensure that you have this kind of continuous operations. Now, everything I've been saying so far, I think, holds true really for the whole data analytics stack. So when you are thinking about figuring out what are the pieces of the puzzle that you need to solve the problem, if you're building an app, obviously you may be using some front-end tools. If you're building a BI dashboard, a set of BI dashboards, you may be using one of the latest, greatest BI technologies. You're using Spark, you're using Databricks, you're using various other types of data platforms, etc. Whatever you do, I think these principles should hold. I'm going to now step down one level into the data integration framework then that we have built out at StreamSets in support of and then to enable this data ops wave. And really, at the highest level, it falls into those three buckets, right? So when it comes to data integration, and when we think about designing for change, it really starts with the data pipelines. The pipeline is a unit of work for data integration, and what we see is that we need to do two things with those pipelines. One is that they need to be smart. I'll talk a little bit more about that. And the other, of course, is that we want more and more people to be able to build these pipelines, so self-service. In the DevOps space, in the monitoring and automation space, there's really, I think, not too much that's unique. It's just that when you now have these pipelines, when you have lots of people using these, you want to make sure that the basic ideas around continuous integration, continuous deployment, continuous testing, etc. holds. And then once you've done that, what we believe is that the topology is really the abstract, the data construct that helps the business understand what's going on. Because the topology is the end-to-end piecing together of these pipelines in support of a business process. I'm highlighting a few of these pieces that I think are critical to delivering a true kind of data ops, data integration technology. So when it comes to the pipelines, what we need to look at is that resilience to drift. So the more you define what the current state is, the more you have to define the schemas, the more you have to define kind of the detailed logic of these pipelines, the more likely it is that it's going to be out of date very soon. So if you can make this schema light, if you can make these pipelines what we describe as intent-driven, and if these pipelines can be loosely coupled both to each other, so you can kind of make changes to related pipelines very, very easily, but also to the infrastructure. So the biggest pain points in data integration is actually around upgrading the sources and upgrading the platforms and upgrading these infrastructure, et cetera, because the pipelines themselves are actually tightly coupled to the endpoints and tightly coupled to the logic, the plug-in logic that comes in. So if you can kind of make that looser, then you got much more ability to deal with that change. When it comes to the automation and monitoring, the real, you hear again a lot about systems the monitoring, things like data dogs and whatnot. The one key thing that's needed in data integration for data ops is being able to monitor the data while it's in motion. So what that means really is not looking at it once it's landed, but if you can actually introspect and parse and profile and sample data as it's flowing through, you can learn a lot. You can apply things like AI and ML into that data set, the metadata, so to speak, and you can do a lot more. And that's really the enabler for then being able to deliver this on this value on this promise of emergent design. So once you can do that, you can then actually deliver what we call policy-driven SLAs. So the pipes are working, they're flowing data. You can, after the fact, define policies around data breaches, around data quality, that can effectively go and inspect these smart pipes and then deliver the right answers and value to the business. Now, of course, I think that's the data ops piece of it, but there are, if you're looking at a proper full data integration solution to solve your data analytics problems, you've got also the actual capabilities that are your data integration capabilities. So you want a comprehensive set of capabilities. Obviously, the data platforms are a no-brainer, but I want to spend a few seconds just talking about the other two. So when it comes to connectivity, I believe that the most important thing is actually the third idea, which is a notion of having open APIs around connectors. So instead of getting stuck and having to wait for technologies to catch up, you can actually have kind of a crowdsourced approach to connectivity. And when it comes to these patterns, it's really moved on well beyond your traditional what people talk about as ETL. ETL was a pattern of joining information, augmenting, enriching information, and kind of writing it into, let's say, warehouse-like formats. But now you've got a variety of different techniques, and really a good platform should be able to solve all of these patterns. Everything from moving from batch to streaming ingest, the ELT pattern, of course the machine learning pattern, being able to push down jobs to the data platforms as needed. So there's a lot of complexity in there, but that's something I think people should be watching for. And of course, in terms of fully delivering, we still need all the minimum market requirements around enterprise-grade capabilities. So I'm going to now just jump in for a few there's no demo here. I'm just going to talk a little bit about the StreamSets pieces and how we've how we started off, how we've architected our solution. We really started off from day one thinking about the cloud. So we embraced containers and Kubernetes from day one. Our technology ultimately then can seamlessly be moved across between clouds, all the public clouds, private clouds. Because they're containerized, they can also still run on cloudless environments, just the traditional way. And the three kind of workhorses that we have are in what we call the data plane. So that provides all those data patterns that we were talking about in the previous slide. Everything from being able to embed agents on edge devices and do what's described as data shipping, so you can filter forward, make decisions on the edge, to a traditional concept of ingest, which is collection of data, from usually outside a compute cluster, from applications, etc., and sending that down. Typically in the collection phase, there's a good amount of cleansing and sanitization that can be done. Think of it as like row in, row out sanitization can be done in that phase. And then once it gets into a compute cluster, you can do the heavy lifting. You can do the ETL, ML, those sorts of the joining and machine learning type algorithms. So the data plane, again, can be deployed anywhere and should be deployed where the data is. So obviously in the edge, you deploy it on the edge. Depending on the locality, where's your origin, where's your destination, you'd have to make that call. What we do with our technology is that we have another kind of parallel set of technologies that enables what we call control and monitoring, management monitoring. So the control hub is the technology that can start really making sense of these different pipelines that may be joined together and provide that kind of topology and data provenance. And of course, Control Hub also then can provide the basic DevOps capabilities around providing a repository for your pipelines and allowing for that kind of CI/CD and continuous integration testing capabilities. The third layer of the puzzle for us is what we call our Data Performance Manager and our Data Protector. These are now the technologies that can then use the probes that are sensors that are built into these pipelines and really start making sense from business value perspective what's going on here. So how does this look from, if that was kind of like the conceptual view of what our products do, what does it look like in an enterprise? So this is a schematic that we get from pretty much every one of our enterprise customers, because what they put is, and they don't even know when they start off, but there's typically some set of data sources that they care about, so they'll put some boxes and identify a few, and as we kind of talk to them a little bit more, we'll find there's more and more, some today that already exist, and some they're expecting in the future. So that's step one. And typically then they've got some idea around what the actual end application is. It could be BI, it could be an application. Sometimes they don't even know. It could just be depositing that data into a technology like Kafka, so just publishing data for the sake of publishing data, right? So it could be any of these use cases. And then really, as you start kind of then asking what's happening to the data, typically there is some sort of a progression of refinement of this data. So there may be a cleansing stage, there may be an enrichment stage, it gets more curated, there could be a learning phase, a scoring phase, etc. So this pipeline this is again a schematic, it can get quite complicated very quickly. Now interestingly in all of this, it could very well be that you can see the message queues are the destinations and the message queues are the sources. So in the simplest form, it may just be get some data out of a message broker like Kafka, put it back into Kafka. But in the complex form, it becomes a full-fledged topology here. So that's really your data flow architecture. And you can, in the blue, you'll see a lot of different potential modes in which these data flows need to happen. And really, everywhere there's an arrow, StreamSets can be used to create those pipelines and manage those pipelines. And really, as I mentioned around that loose coupling, the value here is that you can deploy it on any platform, but you can actually also change your mind. So you can actually see, how does this work if I use, Amazon EMR? How does it work if I use Azure Databricks? These are sorts of things that you can do without having to go back and redo your pipelines. On the control plane side, then what happens is that you can think of it as a single process that you want to understand. So if it's a particular dashboard, you can kind of trace the lineage of this information back to the source. And now you actually know, okay, well, I know it came from these particular applications, these particular databases. This is the traditional metadata management problem that people have done after the fact and spend a lot of energy on. The system automatically can make sense of this. And once it makes sense of this, it can either expose it through our own viewers, or we can also integrate it with catalog technologies and other technologies that you may have chosen as your enterprise standards for things like catalog, MDM, data protection, etc. So go fast and be confident. That's basically what our motto is. It's here. So I want to just give you a few examples of kind of how some of our customers, it's as I mentioned, we're a global company, so I picked one from 3 different continents. The first one is one that we don't typically like, but it is a Department of Defense, 100 million devices, 25 million people in this country, so hopefully you can't see what the country is. They're actually a publicly referenceable customer of ours, and what are they doing? They're bringing all cyber data into a single data lake, and really doing machine learning in support of their kind of BI dashboards and whatnot. The second example is Shell. From 100 million, now you're talking about 100 billion data points in their data lake. Now this is basically end to end. Now they've got 42 what they call operating assets, some of which are generating 100,000 items per minute, all the way to the retail side. They've got 48,000 retail outlets, 1 million business customers, 100 million consumers, etc. And what they've done is really built a data science center of excellence. They have 150 what they call AI engineers and 600 what they call citizen data scientists, all working in concert to operationalize and push these capabilities back into their preventive maintenance applications and into their Shell mobile applications, etc. So that's a great use case around operationalizing data science. And the last one is a US-based company. If you're familiar with things like Venmo and PayPal, there's a company that actually, and I think this year they're doing $200 billion worth of transactions through this application. It's 30 different banks, all using this technology to do peer-to-peer transactions. And you can imagine the value of real-time, basically risk detection and prevention. So that's basically what they're doing. So this is a classic, very simple application. If you look at the application, it'll be send, receive, and you're done. But underneath it, StreamSets is the technology that's moving those massive amounts of data. So just in conclusion, I think people are already taking, I think, these principles that I've been talking about, they've put it into production, they're being very successful. This term DataOps, I know we had a DataOps theater here last year, but I think the term is getting more and more adopted. You hear everybody talking about it. I don't think there's such a thing as one vendor that's going to solve your problem for you. I think everybody needs to work in concert. We do work. We've got a great ecosystem. We work with all those technologies that I talked about, Databricks and Amazon, Azure, etc. But I think together, from the vendor side, we can solve it. So my ask of you is to take some of these ideas, think about it, see how you can apply it to your next projects, your next data analytics projects, and I wish you luck. Thank you.